We're going to get into the geometry behind it. The algebra behind it, why it works. So this whole idea of writing it out, that means to expand, right? In the world of powers, the whole thing is called a power, right? In the world of powers, exponents show repetition, right? So if we talk a little bit just in vocabulary, if I have 4, that's dead, 4 x to the third, right? That would mean 4x, x, x, right? That's expanded. That means to make it bigger, expanded. And a really common misconception when we start rushing with powers, with exponents, is that we think that this exponent of 3 would mean that it's 4x, 4x, and 4x. It would be the whole thing 3 times. But we have to remember that exponents only belong to what it touches. And that can be something that kind of trips us up when we're not taking our time and really thinking through it. For example, negative 2 to the third is negative, and then just the 2 repeats. Because that exponent of 3 only touches the number 2. It does not touch the negative. That negative 2 to the third. 2 to the third with a negative in front of it. The difference would be if it was in parentheses. Because the exponent of 3 touches the parentheses, meaning that the negative is inside the parentheses, so it is carried on. The exponent only belongs to what it touches. There is a difference. The solution might not vary, depending on what the problem is. But whether or not that negative travels is important. And that negative only travels with it if it's inside parentheses. Another part that we might want to talk about is just some vocabulary. 4 to the third. The number 4 is called the base. It's what the exponent touches. So identifying the base. The number 3 is called the exponent. And the whole thing is a power. So the great thing about algebra, right, is that most of algebra is just combining stuff and manipulating it and putting it together or moving it apart, right? We've got these rules that we can follow. So if I give you a problem that looks like 3x to the third y to the fourth times 8xy to the second times negative 6x to the fourth y. This is a power times a power. I'm multiplying powers, correct? This would be an entire power. This would be an entire power. And this would be an entire power. It's a power, a power, and a power. Sometimes you'll just have 2 multiplied together. Sometimes you'll have 3. Sometimes you could have 10, right? Powers times powers. So if we just go off of the basis of what does this look like? When in doubt, write it out. I can expand it. And what that looks like is this. 3x to the third, y to the fourth. 3, 1, 2, 3. 1, 2, 3, 4. Do you agree? 3x to the third, y to the fourth. And then this guy right here would look like 8x, y, y. And this one is negative 6x, x, 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 y. Do you agree? I took each power and I expanded it, right? I took the first power and I expanded it, wrote it without variables. Second power and expanded it, wrote it without variables. And the third power and expanded it and wrote it without variables. And then once you write it without variables, you can rewrite it with variables. Because I know I can do 3 times 8 times negative 6. Negative 144. 3 times 8 times negative 6. 3 times 8 times negative 6. And then I know that there's 1, 2, 3. X times x times x is x to the third. X. X, 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 x. So there's 1, 2, 3, 4, 5, 6, 7, 8. It's x times 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 x. Which is x to the 8th. And then I have 1, 2, 3, 4. Y times y times y times y times y times y times y. Which would be y to the 7th. So, I mean, that's what we're doing. When we're multiplying powers, this is what we're doing, right? We are taking it and we are saying, okay, my coefficients, I can always multiply numbers, right? If there's a number, a value, a numerical coefficient, and another numerical coefficient, and it's asking me to multiply them, I can do multiplication. It's where we get the variables, where I don't really have an answer. My calculator doesn't help me with variables. However, when I write it all out, I expand it, right? I have all of these things that I can collect because they're like terms and rewrite it. So instead of taking all of this time, instead of saying, you know what, I'm going to expand it, then I'm going to rewrite it and then get an answer, right? Instead of that, we have a rule. So we multiply the coefficients when it's multiplying. I multiply my coefficients. And add the exponents. I multiply the coefficients, bam, 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 and add the exponents. Multiply the coefficients and add the exponents. And if you look, 3 times 8 times negative 6 gives me negative 144. 3 plus 1 plus 4 makes 8. And 4 plus 2 plus 1 makes 7. So that's why the rule works. Let's do page 87, powers to powers. Let's two birds with one stone today. Up. Got it. Powers with powers. You'll have to go back to your table of contents. I'll give you a second to write that in there on page 87, powers with powers. So we multiplied powers, right? We talked about our rule, we talked about why the rule works. Now we're going to do powers with powers, which is really powers inside of more powers, right? It's like nested. It's like a Matryoshka doll, right? A Russian nesting doll. Keep opening it up and there's just more inside of it. So many exponents. So again, to talk about why this works, the old hand, the saying is always going to be, if you can't remember the rule, when in doubt, write it out. And this one, powers with powers, I think that writing it out sometimes is the most helpful. Because again, expanding it lets you see what's going on. And sometimes expanding it is going to be the big deal, especially when we get into really big, kind of ugly looking problems. So for example, if I gave you, let's start out simple, right? 4x to the third to the fifth. So I've got a power inside of a power, right? I've got a power. It's a nested problem. If I was going to expand that, that would look like 4x to the third, 4x to the third, 4x to the third, 4x to the third, 4x to the third. Do you agree? If I was to expand it, now you could even go as far. I don't recommend this as much with you guys, but you could continue expanding it. Couldn't you? I mean, talk about overkill. But you could say, okay, this is 4x, x, x, and this is 4x, x, x, 4x, x, x, 4x, x, x, 4x, x, x, right? You could continue to expand it and say, okay, I don't want any exponents. However, if you understand this rule, I think just that one expansion kind of lets your brain see what's going on. Because the solution, the answer, can I squeeze it over here? 4 times 4 times 4 times 4 times 4, which is given up here, right? You can do, it's a really big number, do you agree?
It's 1,224.
So I'm just going to put 4 to the 5th. My kind of rule is if it's greater than 200, I'm just going to leave it in exponential form. But you could write 1,024. I mean, it's not too big. And then I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or 3 plus 3 plus 3 plus 3 plus 3, x to the 15th. Or, Phoebe, what did you see?
That you can multiply the exponents.
You could multiply the exponents. Let's try a little bit bigger. Let's combine some information. Let's do 3x squared y to the 5th to the 3rd. So if I wanted to expand it, right, I wanted to take it because that's a little messy looking, I could write 3x squared y to the 5th, 3x squared y to the 5th, and 3x squared y to the 5th. I could expand it. If you wanted to go crazy, could you continue to expand it one more time?
Yes.
Yes. That sounds like a lot of work. I don't recommend going that deep into the rabbit hole.
I would expect.
Right. But there's no shame in that game. Like if that's how you see it, then that's how you see it. Right? There is no. Some people just like it. It's calming. 2, 3. Ah!
You're really small on your line.
I made it. I get it. Some people like the way that it looks. You're crazy. No, you're not. But it's there, right? Or I could go up here to this first expansion and use my rule, multiply the coefficients and add the exponents. 3 times 3 times 3, that's small enough I can do. 27. 2, 2, and 2. Don't, though, it's sometimes hard to switch between the multiplying and adding. I multiplied my coefficients, so that I'm not going to do 2 times 2 times 2. I'm going to do 2 plus 2 plus 2. X to the 6th. Y to the 15th. Okay, so Phoebe said you could multiply the powers, correct? But here's a trick that you have to do.
You have to put your coefficient to the power.
You need to change the coefficient, if there is a coefficient, right? The number, to an exponent of 1. If you do this, if you change that coefficient to an exponent of 1, then you can use the shortcut. If you change the coefficient to an exponent of 1, then you multiply the outside exponent to the inside exponents. If you change that coefficient to an exponent of 1. Don't forget that part. People tend to forget that. And they're like, oh, Mrs. Long, look, did you know that 5 times 3 is 15? I'm like, yeah, you're right. Oh, did you know that 2 times 3 is 6? I'm like, you are correct. And they say, did you know that 3 times 3 is 9?
Wait.
No. One times 3 is 3, so it's 3 to the 3rd, which is 27. You have to go through and do that part. All right, I'm going to give you a big guy. Are you ready?
Yeah.
I don't even know the answer yet because I'm just making it up.
Okay, let's do it.
Okay. let's use orange again. All right. It's going to be big. Don't be scared. 4x to the third y squared times 3x to the fifth y to the fourth to the third. Ooh. Squared.
What demonic thing have you made now?
I mean, isn't it beautiful? So this is truly, we need to do a little bit of expanding before we start applying our rules. Because if we just start willy-nilly going for it, we might lose our minds, right? So, order of operations says, please excuse my dear Aunt Sally, right? Order of operations says I need to start inside and work my way out. Yes? So let's do this guy first. Then do this guy. Then multiply them together. And then square it. So this guy goes first. You could expand it, right? Sounds a little crazy to me. It's a lot of writing. Or I can change my coefficient number, right? Coefficient is the number, to an exponent of 1. And multiply the inside exponents. Or if you really wanted to, you could write 4x to the third y squared times 4x to the third y squared. This is the same thing as this. Do you agree? So I get 16 x to the 6th y to the 4th times 3 times 1 is 3, so that's 3 to the 9th, or 3 to the 3rd, which is 27. Five times 3 is 15. And 4 times 3 is 12, which I get. 5 plus 5 plus 5 is 15. 4 plus 4 plus 4 is 12. I'm good. So I did these guys, got to here. It's still inside parentheses and it's still squared. So now I need to multiply these to simplify my 16 times 20. You could expand it all the way, right?
16 times 27.
Is 400 what?
432.
32. I have x to the 6th, and I have x to the 15th, which makes x to the 21st. I have y to the 4th and y to the 12th, which makes y to the 16. Squared. I can rewrite that as 432 x to the 21st, y to the 16th times 432 x to the 21st, y to the 16th. And go from there. Or if I remember to change my coefficient to an exponent of 1, I can use the shortcut. 432 squared sounds big, so I'm going to leave it as 432 squared. (21) times 2 is 42, and y to the 32nd. What is 432 squared?
186,624.
Say it again. 86.
624.
Phoebe did that in her head. Don't worry, guys.
No, I use a calculator.
Okay, so multiply. Yes? There are some tricks.